All right, let's talk about regular expressions. So regular expressions are a big part of Unix. Um, they're built into a number of languages: Perl, Java, Bash scripting. Regular expressions are basically a souped-up version of wildcarding, and they're useful, for example, for searching for things, but also for editing, usually text files, and doing replacements in very sophisticated ways with just a few keystrokes. They can be confusing at first, but if you learn a small set of concepts around regular expressions, you unlock a lot of power. So if you can buy a whole book on regexes, but we're going to work with a pretty small subset. And on the top of the problem set, I've got a sort of little half-page summary of the things that we'll be going over in this video. So anchors, basic wildcard, multiple copies of wildcard, something called registers, and so on and so forth. So we'll start digging through these momentarily. There's a number of places we can use regular expressions, but for the sake of demonstration and practice, VI is a pretty good way to play with this. So I'm just going to edit a file, and I can type a slash to search for something. So if I want to search for the word int, I can just say slash int, and it moves my cursor to the next occurrence of that. And I could do slash int again, or I can just hit the letter N, which says show me the next occurrence of whatever I just searched for. So there's the next occurrence of int. And if I hit N again, it'll find it inside print, and then it'll wrap back around to the top. So we're going to use VI mainly for exploring regular expressions. And the first thing to know is basic wildcard. So a period is a wildcard. It will match any character of any type. So if I just search for a period, it will find the letter N, and N matches, this regular expression which says, period, match anything. And if I type an N, the next occurrence of anything is the T followed by a space, SUM, semicolon, and then this space, and so on and so forth. So dot is a wildcard like that. So I could search for a space followed by three dots followed by a space. And this will show me any pattern consisting of a space followed by any three characters followed by another space. And so here's one occurrence. There's a space followed by int space. Here's another occurrence, a space followed by FOR followed by space. And those are the only two occurrences. So that's what a dot will do for us. So we can also look for things that occur at the beginning or at the end of a line. And this is something called an anchor. And so a caret and a dollar sign will say, let's look for something at the beginning or at the end of a line. So if I want to find a character at the beginning of a line, I can search for caret period. And it shows me, this space, this space, this space, space, this curly bracket, the letter T, the letter W, the letter A, and so on. And if I want to search for two characters at the end of a line, I could search for dot dot dollar sign. And so there's a pattern that matches character character followed by end of line. There's two characters followed by the end of the line on this line. It didn't match anything on this line because there's nothing on this line. So dot doesn't match anything, but it does match that. There's not two characters followed by an end of a line here. There's only one character, so it didn't match anything there, and it jumped down to this next line. All right, and we can do replacements of patterns by doing something like this. We can type a colon to go down to the command line in VI and say s slash some pattern slash some new pattern. So for example, on this line, if I say substitute I with an uppercase I, right, it will find this letter I on this line, replace it with an uppercase I. And I'm going to use the letter U to say undo my last change so that I don't have to keep coming in and re-editing this file. So let's play around with some substitution. Suppose I want to get rid of the first character on a line. Let's go down. Let's just go back up here to the top. So suppose I want to get rid of the first character on this line. I can say substitute caret period with nothing, right? So the thing between these slashes is what I'm looking for, and the thing between these slashes, which is nothing, is what I'm replacing it with. So this should replace the first letter of this line, a T, with nothing, right? So that's how I can get rid of the first character of a line. I could say substitute the first character of a line with uppercase ABC, and now my first character, T, got replaced with ABC. And these substitutions, we can specify a range of lines we want this to happen on. We can say line 1, comma, line 2, and then type our substitution command. So let's say I want to get rid of the first character on each line. I can say colon, 1, comma, and $ means the last line of the file. Substitute the first character with nothing, and it just got rid of the first character on each line. If instead I said something like this, substitute any character followed by the end of the line with nothing, this will get rid of the last character on each line, just like that. All right, so that's what anchors are about, and you know, two main anchors. Caret is beginning of line, $ is end of line, and one wildcard period. We can already do a whole lot with these things. For example, I could say, let's just go from here on down. So I'll say dot, which means my current line, comma $, which is the last line. Let's substitute beginning of a line followed by 2 spaces with 8 spaces. And that's going to, you know, indent all of my indented lines, 8 spaces instead of 2. So regular expressions are good for searching, but in particular, a lot of times the reason we're searching is because we want to replace certain things. So let's say instead of printf, I wanted to say fprintf. I could say 1, comma $, substitute printf with fprintf, and anywhere that I had an fprintf, that would get replaced. If I wanted to replace int with long int, I could try doing something like this. But, you know, my print changed into pr long int instead of print. That's not what I wanted to do. So I could do something a little more detailed. Right, I could say any int that begins with a space, let's replace that with long int. And now it will just pick up this long int sum. So using regular expressions is a little bit like playing a puzzle box. We have a small set, very small right now, but when we're done, a little bit larger, small set of things that we can use, and we're trying to figure out how to put these together to get certain behaviors. Alright, so we've really only been playing with 2 things so far, a wildcard and an anchor. An asterisk will match 0 or more occurrences of something. So let's, let me put some more test code in here. Alright, so I've got a bunch of repeated i's. Suppose I wanted to find any occurrence of repeated i's and replace them with just a single I. So I could say let's replace an I followed by 0 or more occurrences of the letter I. And let's just replace that with an uppercase I. All right, so this regular expression, this is the letter I, and this I star says 0 or more i's. So anywhere I find an I followed by 0 or more i's will get replaced with an uppercase I. And if I do that, right, this line where I had a bunch of i's got replaced by I. So did this I in int, so did this I in printf, so did this I over here. So if I only wanted to change, you know, occurrences of 2 or more i's, I could do something like this. Let's replace 2 occurrences of I followed by any number of subsequent i's with an uppercase I, and this will be the only place where that pattern matches, so that gets changed to an uppercase I. So if I wanted to change all my leading spaces to be a tab, and I just hit the tab key and it showed up as Control I, that's the ASCII code for a tab. So I can substitute beginning of the line followed by a space followed by any number of spaces, and I'm going to replace that with a tab. So now I've moved all my lines over so that they're indented exactly 1 tab, no matter how many spaces there were. Now if I wanted to just change my indenting so that my 2 spaces get replaced by a tab, I can do something like this. Substitute space space with tab. And so, you know, here is a space space, here is a space space, here was a space space that got indented by a tab now, but there's still another space space here, right? Because this line was indented twice. So when you do a substitution like this, it only happens once per line, but I can add a switch /G which says do this globally on each line. So when it gets to this line, it will look for a pair of spaces, which it will find right here. It'll replace it with a tab, and then it'll continue looking for another pair of spaces, which it will find right here, and replace that with a tab. So this will do what we probably wanted, change all of our double space indenting to tab indenting instead. And so if you like tabs, now we've got a nice, you know, tab indented file. So that's this /G at the end, replace all occurrences on this line of old with new. All right, so that's sort of the first half of regular expressions, is searching for things. But, you know, searching is not that complex. If you're looking for something and you don't find exactly the thing you want, you can just use the N key to keep searching, and usually that's pretty efficient. The real power of regular expressions is when we start doing substitutions. So this gets us into what are called registers. Basically, when we match something, we can say, hey, take the thing that you matched and let's copy that into a temporary place, something called a register. And we do that by enclosing the regular expression inside parentheses, and we need these / escapes before each parenthesis. And then if we want to refer to the thing we matched, we can say / and put in a number. The first pattern we match goes into register 1. We can refer to it with /1. The second thing that we match goes into register 2. We can refer to it with /2, and so on. All right, so examples will work better than words in this discussion. So let's suppose we want to take the first letter. Let's just play with these first 4 lines. Suppose we want to take the first letter and move it to the end of, let's just swap the first 2 letters. Let's start simple. Let's just swap the first 2 letters on each of these 4 lines. So I can say on lines 1 through 4, well, let's match the first character with a period, but I'm going to put it inside parentheses. So let's take the beginning of the line, that's the anchor. Let's take the first character, and let's take the second character. So, you know, this is a regular expression, anchor, you know, caret, ... Let's match those 2 characters, but then we're going to replace it with, and I'm going to replace it with what I matched in this second pattern, which I can say \2, and what I matched in the first pattern, which is \1. So this regular expression should take the first two letters, swap them with each other, and there we go. If I wanted to swap the last two letters on each line, I could do something like this. Right, so this would match the last two characters. Right, just dot dot followed by my $ anchor. So all I'm going to do is put parentheses around those two dots and my anchor at the end. And now, in addition to matching those last two characters, it's copying them into these registers, register 1, register 2. So I could replace this with, 3 copies of the last character and 3 copies of the next to the last character. And so now, happening question mark became happening, followed by 3 question marks, followed by 3 G's. Our Z got repeated 3 times, followed by our Y, and so on. So these are the kind of games you can play with these registers. And you can start getting into a lot of powerful pattern matching and replacement by using just this relatively small set of things. So anchors, wildcards, this asterisk, this notion of capturing things in registers, and this / register number to get its values. We haven't even done the things in brackets yet, but we've got a pretty powerful kernel of tools available right now. Let's talk about brackets. So if I say search bracket A-E-I-O-U, this will search for any of these characters. In other words, this will search for vowels. So there's an I. If I hit the letter N, there's another I, A-E, A-I, A-E-I, and so on. So we can put a pattern inside brackets, and that means look for any of these things. I can also put a caret in the front of those, and this is not an anchor. This is now negating our pattern. So this will say search for anything that is not A, E, I, O, or U. In other words, search for consonants. So we find V, W, X, Y, Z, H, and then when I say next, it will skip over the E and it'll jump to the L. This will skip over the O. This will skip over all of the I's and go to the S, and so on. So if I want to find something that's not a particular character or set of characters, I can say square bracket, caret, and then the things that I wanted to not find, and then a closing bracket. All right, so we can get more sophisticated with this, right? If we wanted to swap the first and last characters of our line, so let's work on the first 4 lines. Let's look at the beginning of the line, match a single character, and then I'm going to say match any number of characters, and I'm going to say match one more character followed by the end of the line. So register 1 will contain the first character, register 2 will contain all of the middle characters, register 3 will contain the last character, and I could replace this with \3, \2, \1. Last character and middle first character. This should swap the beginning and end of each of these first 4 lines like that. So what is happening? Question mark became question mark hat is happening with a W, and the Z and the A switched, and so on and so forth. So that's really all there is to regular expressions. And like I say, it's kind of a puzzle box. It's a matter of trying to find combinations of these relatively few ways of describing patterns that will achieve whatever it is we want to do. But there's lots of different types of file manipulation that we can do based on this. And so the problem set we'll be working on goes through a number of these, including some of the things we just did, swapping first 2 characters of each line, removing the second character of each line, or taking a file of names and changing it from first name to last name, comma, space, first initial, right? Things like that. And all of these can be done with just one carefully crafted regular expression. Um, there's websites you can go to that will let you play with this, let you type in expressions and see how they do what they do. It will show you what's matching different parts of your regex and so on and so forth. But VI is a pretty easy way to just mess with this. Make yourself a file, hop in, and just do colon, and you can do these substitute commands to start looking for different patterns and replacing them. So one more example of this. Suppose we wanted to remove the second word from each of these first 4 lines, where the word is, the thing with a space before it and a space after it. So, these first 2 lines, the word is 2 letters long. This line, the word is a whole bunch of letters long. How can we match those patterns? Well, we can use this notion of, square brackets with a caret to negate a pattern. So let's search for a space followed by anything that is not a space. And we're going to ask for any number of those things that are not spaces followed by a space. So on this line, this would match the space, this would match the bracket anchor space bracket star, and then this would match the last space. And let's just replace that with a single space. So that pattern will delete the second word from each of those lines. One other thing to keep in mind about regular expressions, we say regular expressions are greedy, meaning that they will match as much as they possibly can. So for example, if I wanted to try to get rid of this second word on each of these lines, I could search for a space followed by any number of occurrences of a character and replace that with nothing. Well, this is going to match a number of different things, right? A space followed by the letter I. Well, I is certainly a character followed by no other characters. IS is a character followed by one character. IS space is a character followed by 2 other characters. Each of those matches this pattern. So what exactly is it going to match? It's going to try to match as much as possible. And in this case, this means it would match, the space followed by one character, followed by as many characters as it possibly can. So basically everything starting with the first space is going to get deleted by this. So keep that in mind. Regular expressions, if there's ambiguity as to what they could match, if there's multiple patterns that would match what you're typing, it will generally match as many characters as possible. So that's the greedy part of regular expressions. All right, that's the basic overview of regular expressions.